handwriting recognition. Our supervisor is Dr. Humayun Kamahan. First of all, this is the outline of our project. It's going to be about introduction, problem definition and aims, related work, methodology, analyzing requirements, initial design solution, software, hardware requirements, future work.
So, online handwriting recognition research started at the 1960s, and interest in that field has increased in the 1980s. In handwriting recognition, we have two approaches or two techniques. One is online handwriting recognition, and the other is offline handwriting recognition. We're going to use online and handwriting recognition. Online handwriting recognition is recording the stylus movement on the PDA, the personal digital assistant, and convert it into vertices. Then convert the vertices into text. And offline is taking a picture of a written text and convert it into a text. The online handwriting recognition has a higher accuracy than the offline handwriting recognition.
Why?
Huh?
Why?
We read on the research
That doesn't make any sense.
Because,
it's a software package.
Because it's an image. Because it's an image. The image maybe the written text is not written accurately or something like that.
I know that like one time I had to scan like 80 pages. It was a book that somebody wrote. 80 pages. It was like written like 20 years ago on paper. But it was text, printed text, and I scanned it, and it got everything except in 80 pages, one character was wrong. It was my printer.
Yeah.
The basic OCR built into the picture, and built into the printer software.
Yeah.
Misty, Epson printer, Real. I scanned it automatically, but I got a PDF of the actual characters.
Yes.
So it was like 100%. So I don't know. Anyway.
It's dependent on the picture. Sometimes the picture it's not clear.
So that's clear. But my question is why offline versus online? That doesn't make sense. So find the answer to that. Since you're saying you should get an answer.
Yeah.
Like, depends where you're taking the picture from. That's first of all. Second of all, taking like when you're using in a PDA, you're writing. You get the same accurate result that you're writing. So, in the picture, like I said, it depends what camera you're using. If you're using camera, 2 megapixel camera, it's not going to get the same.
Go back to where's your statement? Right? Where you said online.
Yeah, the online handwriting has higher accuracy than offline.
So again, I just since you're quoting him, you should know what he means, right? When you quote somebody. So it's not clear. What you're saying is understandable to anybody.
Yeah.
Yes.
So here it says the online handwriting recognition, higher accuracy than offline. So we're talking about, I'm guessing we're talking about the online. What does it say?
Yeah.
Offline. What is the online?
Online is recording analyzing the status movement all the time.
So offline is by taking the picture.
Yeah.
Yeah. Now that's clear.
I said it earlier.
Wasn't clear. So you read it. So online is the recognition of the movement of the stylus versus offline is just taking the picture.
Yeah.
Yes.
So now it's clear.
What has motivated us to do this project is that now technology is faster. It's going faster every day. And we need a new way to enter data into the computer. So we will get the people solution to let them write manual.
Okay, project objectives. Our objectives in this project is to enhance the handwriting recognition algorithm, to enhance the handwriting recognition accuracy, to develop an easy, portable, and intelligible handwriting application that recognizes Arabic handwriting.
Offline or online?
Online.
Online.
Online, yeah. Problem definition. Problem facing handwriting recognition would be the accuracy of the recognition, the algorithm speed, and the language character set. And related work, research, our doctor helped us find some papers, and we found some papers as well. And what is interesting from these papers is the greedy point match handwriting recognition. It's talking about, we have two algorithms, greedy point match algorithm and a vector algorithm. The accuracy of the greedy point match algorithm is going to be not 80%, and the vector algorithm will be 90%. So, but the greedy point match handwriting recognition algorithm has a problem. It's very slow. Okay, and the vector is very fast. And so what we're going to do in this, what he's going to do over here, the vector algorithm will be analyzing the text at the beginning to filter it, then go to the greedy point match algorithm to make it faster, and the accuracy will be, and it will be 34.6 times faster. And the greedy point match and the vector together, but when they're binding together, the accuracy of the text, the output will be 98.6%. So yes, next.
We have seen some related applications to our project. This application is an Android application, Magic 3. It does allow you to write text messages with handwriting on the screen. The other one, it replaces its right pad for Android. It replaces the keyboard with handwriting, but does not support Arabic language. Methodology, like my friend said earlier, we have our supervisor provided us with some papers, and also we use Google Scholar to find other papers.
Okay. Analysis and requirements. Functional requirements, the system should provide training for the user. That means the system that takes the uses the trained data to get the better result in the future. That means we need database. The system should recognize Arabic writing. The system accepts Arabic handwriting as an input and convert it into text. Non-functional requirements. First of all, we have usability. The system should be easy to use. Performance. The system should have high accuracy rate for recognition. And the system should be fast in recognizing the characters. Reliability. The system should have fault tolerance and accurate result. Availability. The system should be available in all times and providing alternative versions. Like if when you write something on the screen, okay, it would fault tolerance if it doesn't work correctly, so it wouldn't have breakdown or something that it will bring something else. It will let you write again on the screen. So it's like telling you it doesn't understand. It will reboot itself. Understand?
Here's the initial design. We designed a flow chart. So we will start by analyzing the written text on the PDA, and then we do a character segmentation. Then we fetch a character to the server. Then search the database for this character by searching for the attributes. Each character has an attribute, like the number of vertices or the space between vertices, stuff like this. And we will set the closest value to this character. If the text finish, we will display the text. If not, we will bring another character. Class diagram. We have 4 classes: the user interface, which is in the PDA, and the recognition class, and OLCR, which stands for online character recognition, and analysis class. This initial design for our system architecture. We will implement client-server-based architecture. The written text will be written on the PDA, and then send to a server, and the server will analyze the text and send it back to the PDA on a digital text.
Software hardware requirements. Java programming language under Eclipse will be used to develop our application. Android application. Microsoft Office will be used to write the report in the project. Photoshop will be used to design icons in our software server and a PDA. Future work, implement and code the application, test the application, try to improve it if this is needed. Any questions?
Same comments as everybody, just